Hello everyone, I'm back with another video, and so today again I'm going to be talking about halohydrins. So I know I have another video on it and I'm going to briefly show it. So here I have the halohydrin and I show you how to make it an anti-periplanar position. If you haven't seen the video, go check it out. One thing I want to say, I don't know why I had anti-Markovnikov, it's just anti-addition. That's what you need to know about this reaction as well as the halogenation reaction. Now, why did I make this video? I made this video because I wanted to show you how you can actually form enantiomers. So in the other video, I showed you how the Br and the OH were in anti-periplanar position. But I told you that the alkene itself wasn't chiral, and so you didn't form any enantiomers. Well, I made a molecule that is going to have chirality. So that way you will form enantiomers, and you will see why you form enantiomers, how you form them, and all of that good stuff. So let's get into the actual mechanism. So as you know, it's halohydrin, so you're going to have the halogen first, and then the water is going to come into play. So you're going to have these double bonds. This alkene, which is a pair of electrons, is going to go and attack the bromine. Then, how I said explain it is that way I like to think about it is that bromine is very electronegative. It's going to be attracted to that carbon, because carbon is more electropositive. And then you're going to have those other pair of electrons between the two bromines go to the other bromine, so bromine 2. Great. Then what happens is you form bromonium, and I'm going to make emphasis because you guys get it wrong on the exams, is you don't write your positive charges and your negative charges. The formal charge is very important. If you don't know how to calculate formal charge, go check out my video on that. But notice that bromine in this is positive because the formal charge is positive. 7 minus 6 is 1, so it's going to have a positive formal charge. Now what's going to happen? Water comes into the reaction. Water comes and attacks the most substituted carbon. Then those electrons are going to push bromine up. Great. Now, why do you form enantiomers? That should be your question. Why do you form it? Water can attack from the front or it can attack from the back. So let's get into that. Water attacks and the bromine goes. So let's say water attack from the front. I have water attaching. The blue is supposed to be bold, so please imagine that in your head. So again, it's going to have positive formal charge because again, if you calculate it, it's going to be positive 1. Then bromine is going to attack the hydrogen, not the oxygen, the hydrogen. And then those electrons are going to go to the oxygen. And so this would be 1 enantiomer. And notice that the bromine and the OH, they are anti-addition. The bromine is in dash, the OH is in bold. But what happens if the OH didn't attack from the front and it attacked from the back? Now let's draw that. So now I'm going to draw OH going to be in, the water going to be in dash. Again, it's going to have a positive charge. Bromine is going to attack the hydrogen, and then those electrons are going to go to the oxygen. And then you're going to form your other enantiomer. Again, the bromine is going to be in dash. I mean, not in dash. The bromine is going to be in bold, and the OH is going to be in dash. And so again, you have this enantiomer of anti-addition where you have the bromine in dash and the OH in bold. And in this enantiomer, you have the bromine in bold and the OH in dash. And notice the methyl goes accordingly, right? So this OH is in bold, this methyl is in dash, this OH is in dash, this methyl is bold. So I'm going to take out all those highlighters because it won't let you appreciate the color. But I want to make emphasis that in this reaction as well, you're going to have anti-addition. Again, if you liked this video, please like, follow, and share. I want to help as many students as possible because I know organic chemistry is a very grueling subject for most students. And so please also let me know if you have any questions or mechanisms you want me to go over, and happy studying.